A 20-story building can collapse straight down into its own footprint in under 10 seconds, missing structures just feet away on every side. This is not luck, and it is not really about the explosives at all. Every second of that fall was planned months in advance, down to the millisecond, by engineers who spend most of their time thinking about how a building will fail rather than how it was built to stand. Most demolitions do not use explosives at all. Wrecking balls, excavators fitted with hydraulic hammers, and slow floor-by-floor deconstruction handle the vast majority of teardowns worldwide because they are cheaper and give crews far more control over the pace of the work. Implosion is reserved for a specific, narrower problem. A large concrete or steel structure sitting so close to other buildings, active roads, or buried utility lines that a slow mechanical demolition would either take too long or risk destabilizing the structure unpredictably, as it is picked apart piece by piece over weeks. When a building has to come down fast, cleanly, and entirely within its own footprint, with almost nothing left standing afterward, controlled implosion becomes the only practical option left on the table. The real work starts months before a single explosive charge is placed. Structural engineers pull the original architectural blueprints, then physically survey the building floor by floor to confirm the plans still match reality. Because older buildings often carry decades of undocumented renovations, added walls, and reinforcement that never made it onto any drawing. Engineers identify every genuinely load-bearing column and shear wall, the elements actually carrying the weight of the building above, as opposed to the partition walls that could be knocked down with a hammer and change nothing structurally. This survey tells engineers exactly which supports need to fail, in exactly what order, to make the building's own weight do the work of collapsing it inward instead of tipping over onto whatever happens to be next door. Once the load-bearing supports are fully mapped, crews drill directly into the concrete columns and pack them with dynamite or other high-explosive charges, while steel beams and girders get linear-shaped charges instead. A thin explosive strip that cuts clean through structural steel like a blade rather than just cracking it apart. Charges are placed on selected columns across only the lower few floors of the structure, never the whole building from top to bottom. Removing the supports on just 2 or 3 key floors near the base is enough, because once those specific columns are gone, the enormous accumulated weight of every floor above has nowhere left to go but straight down, crushing the floors beneath it in sequence on the way to the ground. This is the part that actually determines which direction the building falls, and it has almost nothing to do with the size of the explosion. Every charge is wired into a computer-controlled detonator system, and critically, the charges do not all fire at the same instant. They go off in a precise, pre-programmed sequence, sometimes only tens of milliseconds apart, starting with the columns on whichever side engineers want the building to lean toward as it falls. Those supports vanish first, so that side of the structure begins dropping a fraction of a second earlier than the other side. That tiny head start, invisible to the human eye in real time, is what tips the building's enormous mass inward and downward instead of straight down onto its own basement or sideways into a neighboring structure. Even a perfectly aimed implosion still generates 2 serious problems: flying debris and a wall of dust that can travel for blocks. To manage the first, engineers wrap the lower floors in heavy geotextile fabric and steel chain-link mesh, physically catching concrete fragments before they can be thrown outward at speed. To manage the second, crews pre-water the site and often the building's interior right before detonation, because wetting the concrete dust as it is created keeps individual particles heavier and prevents them from billowing outward as one massive airborne cloud that could travel far beyond the site. Roads and structures within the calculated danger radius are fully cleared and monitored in the hours before, and vibration sensors bolted onto nearby buildings confirm in real time that the ground shock from the collapse stays within safe structural limits. A building that took years to construct is engineered to come down in just 6 to 10 seconds, and depending on complexity, the planning phase alone for a single implosion project can run anywhere from a few weeks for a simple, isolated structure to 6 months or more for a complex high-rise with unusual geometry or dense surrounding infrastructure. In March 2026, demolition crews in Powell River, Canada used this exact method to bring down the Power Boiler 18 structure at a former paper mill site, using precisely sequenced charges to drop it straight into its own footprint without touching the surrounding mill buildings. It is a strange kind of engineering achievement. The entire goal of months of planning is to make something incredibly complex look, for about 10 seconds, like simple gravity doing all the work on its own. Given how much can theoretically go wrong with deliberately detonating explosives next to occupied buildings, implosions have a remarkably strong safety record, and that is entirely a function of the redundancy built into the planning stage rather than luck on the day. Engineers run structural models of the collapse sequence long before any charge is placed, checking that the predicted fall direction and debris field stay inside the cleared radius under a range of scenarios, not just the ideal one. Independent inspectors typically review the charge placement and wiring before detonation as a second set of eyes. And the actual detonation is almost always delayed to early morning hours specifically, because that is when surrounding streets have the least pedestrian and vehicle traffic, adding one more layer of margin on top of an already heavily engineered outcome. Next time you see a building drop straight down on camera in under 10 seconds, remember it took months of structural mapping, hundreds of individually placed charges, and a detonation sequence timed in milliseconds to make it look that effortless.